Jai Jagannath. Welcome to More Physics. So, dear friends, this video is applicable, or you can say it is useful for engineering physics, engineering semester examination, then CBSE, ICSE, CHSE in class 12th. So, I am referring this book particularly. So, actually, this book is a very beautiful book. This is University Physics. So, I am taking 30th edition. So, author is Young, Friedman, and Ford. So, let us start with electricity and magnetism. So, first we will discuss the chapter 21, that is electric charge and electric field. So, now you see the total electromagnetism subject is actually very important subject, because it is applicable for all the engineering students and medical students, because electricity magnetism is application of this electricity magnetism is in various wide field. So now in electromagnetism, so there are two units. One is electrostatics. Another is electrodynamics. Now in electrostatics, what do you mean by electrostatic? You see, the electrostatics consist of two words. One is electro, another is statics. Electro comes from the word electron. So electron is a charged particle. Okay. Statics means what? Rest. So a subject which deals with a charge at rest is called electrostatics. So what is the topic of discussion in this electrostatics? In the electrostatics chapter, we will discuss the charge, the concept of charge, then electric field, and electrostatic potential, and finally we will discuss the capacitance. So these are the topic of discussion in which subject? Electrostatics. Then what is electrodynamics? So in electrodynamics, that is, dynamics means motion, electro means electron, that is charge. So when charge moves, what are the various effects? We will discuss in this topic, that is electrodynamics. So electrodynamics means charge in motion. Electrostatic means charge at rest. So in electrodynamics, what topic we will discuss? First is your current electricity, or you can say electric current. Then we will discuss the magnetism chapter. What is the magnetic effect of electric current, like this? So we will discuss later on. So this is your magnetism. Then electromagnetic induction. So we will discuss elaborately in the coming classes. Then it is AC, alternating current. So first we will start. In this chapter we will start electric charge and electric field. So what is electric charge? What is the concept of a charge? So now we will discuss what is the concept of a charge. What do you mean by charge? You see, just take an example, sodium atom. So atomic number is 11, mass number is 23. So what do you mean by that? In this sodium atom, how many number of protons? So number of protons is 11, which is also equal to number of electron. Then what is the number of neutron? Number of neutron is mass number 23 minus 11, that is 12. So if you will see the atomic structure, so inside the atom there is nucleus. In the nucleus there are how many proton? 11 proton. And how many neutron? 12 neutron. Surrounding to the proton, electrons revolve. you have read in the chemistry. Surrounding the proton or nucleus, electrons revolve. In the first orbit, what is the number of electrons? In the first orbit, the number of electrons revolve is 2. In second, it is 8. And you see how many electrons are there? 11. 2 plus 8, 10. So the outermost orbital electron is 1. Okay. So now this electron, the outermost orbital electron is called free electron. Why it is called free electron? Just take an example. Suppose this is your parent, father and mother. So when you are doing play school, okay, so that play school was near to the parent. So here the force of attraction between parent and you is very, very large. So you are more stable. When you will go to 11th or 12th school, you will go away from your parent. The force of attraction between parent and these students or you, the decreases. And when you will go for higher education, engineering, suppose your parent is staying at Bihar, you are reading at Bhubaneswar. So the force of attraction between your parent and you decreases because R increases. So why this? What is the relation? That relation is we will discuss in Coulomb's law. Force of attraction or repulsion is inversely proportional to square of the distance. Now see, the outermost electron is loosely bound by this nucleus. That means this electron is very unstable. So if somebody will say, suppose your friend will come, let us go to park or let us go to restaurant, you immediately go because you are loosely bound by the nucleus or parent. So this electron which is loosely bound by the nucleus is called free electron. Okay, so what do you mean by free electron? If I apply some small force externally, so this electron can remove from this orbit. So that's why it is called free electron. Okay, so now tell me, what is the total charge of sodium atom? Total charge of sodium atom, you can say it is the, so how many protons? 11 into charge of a proton. How many electrons? 11 into charge of electron. How many neutron? 12 into charge of neutron. So you see 11 into, what is the charge of proton? We know 1.6 10 to the power minus 19 coulomb. And what is the charge of electron? Minus 1.6 10 to the power minus 19 coulomb. Charge of proton and charge of electron are same but both are opposite. And that is 12 into, what is charge of neutron? 0. Now you see, this is plus 11 into this is minus into 11 into this. So the total charge of the sodium atom is 0. Clear? Now suppose I will give some external force so that this outermost orbital electron will be free. So if outermost electron is free, that is after applying some external force, this one electron, that is outermost electron, leaves. Then how many protons are there? Again, number of proton is equal to 11. Number of proton is 11. But what is the number of electron? One has already left. So the total number of electron is 10. So charge of neutron, you know, it is 0. Then if somebody will say, now what is the charge of sodium atom? You will say the charge of sodium atom is equal to charge of 11 proton plus charge of 10 electron, because the neutron charge is 0. So that is equal to 11 Qp plus 10 Q. You know, charge of proton is positive 1.6 10 to the power minus 19. Charge of electron is minus 1.6 10 to the power minus 19. So if you add this, you will get only 1 into charge of proton. But 1 into, what is the charge of proton? Plus 1.6 10 to the power minus 19 coulomb. So I can say here the charge of sodium atom is equal to plus the number of electron left is 1. And this 1.6 into 10 to the power minus 19 coulomb is simply written as E. So what is E? So E is equal to 1.6 10 to the power minus 19 coulomb, which is called fundamental charge. That is, it is the smallest charge possible. Smallest possible charge is equal to 1.6 10 to the minus 19 coulomb. So here, if one electron left from the outermost orbit, then charge of sodium atom is equal to plus 1 into E. So that is positive charge. Similarly, if you add, suppose you add one electron to the sodium atom. So if you add one electron to the sodium atom, then what is the charge of sodium atom? You see. So number of proton will not change because it is strongly bounded by the nucleus. You cannot remove this proton. Only you can remove the outermost electron. So, or you can add electron from outside. Suppose I will add one electron from outside. Then what is the charge of sodium atom? So number of proton is 11. So 11 into charge of proton plus. Here, if you add one electron, the total number of electron is 12. 12 into charge of electron. So that is equal to 11 proton charge and 11 electron charge will be cancelled. Only remaining is 1 into charge of electron. Okay, so I am writing here. So then charge of sodium atom is equal to 1 into, what is the charge of electron? Minus 1.6 10 to the power minus 19 coulomb. So you can say it is minus 1 into, I have already taken 1.6 10 to the minus 19 is E. So charge of sodium atom is equal to what? Minus 1 E. So here charge of sodium atom is equal to what? Plus 1 into E. So what do you mean by that? So charge of anybody, you can say the charge of anybody can be positive or negative. Under what condition it will be positive? If there is deficiency of electron. Deficiency of electron creates positive charge. Surplus of electron can create negative charge. We can write charge of any body Q can be expressed as plus or minus Ne. So what is Q? Q is charge of any body. Then what is E? E is the smallest unit of charge. Smallest unit of charge. And N is number of electrons transfer. It is always integer value. And what is positive? Positive indicates deficiency of electron. If there is deficiency of electron, it will create positive charge. And negative means surplus of electron. Surplus of electron. Okay, so this is the charge of anybody. Now, let us say question may come like this: Can a body possess 8 into 10 to the power minus 22 coulomb? Let us take a understanding. So can a body possess 8 into 10 to the power minus 22 coulomb? So option is, first option, yes. Second option, no. Third option, can't say. Fourth option, none of the above. So now, tell me, so which answer is correct? You see, can't say means that does not mean that you are not able to solve this problem. You will write can't say, you will get full mark. No. Can't say means data is insufficient to solve this problem. Okay. So now, solve this problem. You see, we know, I have already discussed, the magnitude of charge can be plus or minus Ne. So if I say the magnitude of charge is equal to Q is equal to Ne. So that implied N is equal to Q by E. So what is the charge value? 8 into 10 to the power minus 22 coulomb. What is the value of E? 1.6 10 to the power minus 19 coulomb. Just take the, divide this. If you divide, you will get 5 into 10 to the power minus 3. So which is equal to 0.005. So this 0.005 is not a integer, it is a fraction. So I have told charge of anybody can be taken as any. N must be an integer. But here you are getting n is a fraction. So if n is a fraction, anybody cannot possess this amount of the charge. So answer will be no. Clear? So let us take, you solve this problem. Just pause this video and solve this problem. So same question. Can a body have charge of minus 16 into 10 to the power minus 16 coulomb? So you can give the answer. Okay, I am solving. You know Q is equal to what? Ne plus or minus Ne. If you take the magnitude, Q is equal to simply Ne. So here Q is value is equal to 16 into 10 to the power minus 16 is equal to N into E is equal to 1.6 into 10 to the power minus 19. So divide this N, you will get N is equal to, I think it is 10,000. So this 10,000 is whole number or integer. So in this case we can say a body that means a body can possess this amount of charge. So answer is yes. Clear? So now we will discuss how the charge is possible. How will you get the charge? How will you create the charge? So first, initially there was a method that is called frictional electricity. What is frictional electricity? Electric comes from the word electron. Electron means charge. City means crowd. That means a huge amount of charge can be produced by some energy. That energy is called frictional energy. So by friction we can produce the charge. Let us, in your childhood career, you have marked, if you will bring a comb and you comb your dry hair. That means when you are combing your dry hair, so you are rubbing. Rubbing means it is a frictional energy. So when you will comb your dry hair, what will happen? After combing, you will observe some charge. This comb will attract very small paper particle or very small paper pieces. That means after rubbing, this comb will possess some power, that is electrical power, which will attract the small particle. So here charge is produced in the comb due to which energy? Friction energy. Let us take another example. You bring a fur and you rub this fur with plastic rod. So you are rubbing the fur with what? Plastic rod. What will happen? Suppose, and due to some material particles, due to some principle, due to some behavior of the fur and plastic, we will observe some electron will transfer from fur to plastic. Okay, so let us assume 2 electrons are coming from fur to plastic. So what will happen? After rubbing, we will see this fur becomes positive charge. And plastic rod becomes negative charge. Why fur becomes positive charge? Here electrons left from the fur. So deficiency of the electron creates positive charge. And here electrons are added to the plastic. So addition of electron will create negative charge. And we will observe, if we will, suppose you will bring 2 plastic rod. Okay, and rub these 2 plastic rod with the fur. After rubbing, if we will bring these 2 plastic rod closer to each other, what will happen? There is a force of repulsion. Why there is a force of repulsion? After rubbing, this plastic rod becomes negative. Another plastic rod will also become negative. This negative plastic rod will repel to the another negative plastic rod. So this will be discussed in the Coulomb's law, because in Coulomb's law, like charges repel, unlike charges attract each other. Okay. Similarly, you take another example. Suppose you will take a glass rod. This is what? This is glass rod. You rub this glass rod with what? Silicon, silken cloth. So if you rub this glass rod with silken cloth, it will be observed glass rod after rubbing, what will happen? So this glass rod becomes positive charge. Silken cloth becomes negative charge. That means what? Since glass rod becomes positive, definitely some electron will transfer to the silken cloth. So that here it will create positive charge, here it will create negative charge. Due to which energy you are rubbing? Rubbing means which you are applying which energy? Frictional energy. So in this case, you will get a charge. Okay. So now you see very interesting result. Before rubbing, I am writing here. Before rubbing, what is the charge of glass rod? Charge of glass rod is 0. What is the charge of silken cloth? It is also 0. Then what is the total charge of the system? Total charge of the system is 0 plus 0, that is 0. Now come to after rubbing. After rubbing, what will happen? After rubbing, what is the charge of glass rod? Let us take 3 electrons are leaving from the glass rod. Since there is a deficiency of electron, how many electron deficiency? Here 3. So what is the charge of a glass rod? Plus 3 into E. And here 3 electrons are added to the silicon cloth. So what is the charge of silicon after rubbing? Minus 3 into E. So what is the total charge? Again total charge is equal to 3 plus minus 3, which is equal to 0. That means before rubbing, the total charge of the system is 0. After rubbing, the total charge of the system is also 0. So what is the conclusion? Conclusion is that charge, this is conservation of charge. This property is called conservation of charge. Conservation of charge means charge can neither be created nor be destroyed, but can only transfer from one body to another. But total charge of the isolated system means there is no interference of other charges. So for isolated system, the sum total of charge is always equal to 0. That property is called conservation of charge. That property is called conservation of charge. I think it is clear. Okay. So now we will discuss some characteristic of the charge. So charge. What is the characteristic of charge? Charge is called, it is the intrinsic property. It is the intrinsic property of a matter, just like mass. So intrinsic property means it is the last property. Suppose you will take a body. What is the intrinsic property of the body? That is mass. Mass is the last property of the body. Similarly, the last property of the body is also called charge. That is called charge is intrinsic property of matter. Intrinsic property of matter. And charge always carries mass. Charge always carries mass. Okay. And what is the unit of charge? Unit of the charge is equal to Coulomb, abbreviated by C. And charge is a scalar quantity. It has no direction. And if somebody will tell what is the dimensional formula of charge? Dimensional formula. So you know Q is equal to IT. I is fundamental unit. Time is fundamental unit. So what is the dimensional formula of charge? It has no mass. Mass is not there. M not. Length is not there. L not. Ampere is represented by A. Time is represented by T. So this is the dimensional formula of charge. Then types of charge. Charge may be positive, may be negative. I have already discussed what is positive charge, what is negative charge. And like charges repel and unlike charges attract. Unlike charges attract which is called Coulomb's law. So if there are two positive charges, they will repel. If there is one positive and another negative, these two charges will attract. Then what is the difference between charge and mass? So if you will see the characteristic of charge and characteristic of the mass. So what is the difference? So charge may be positive or may be negative. But here mass is always positive. Mass is always positive. So second property is charge is independent. Charge is independent of speed. That means suppose this is a body, this is a conductor. Its charge is 20 coulomb. It is at rest. If anybody will ask what is the charge of this body, you will say 20 coulomb. Suppose this conductor, this charged body is moving with 60 km per hour speed. Then again the charge of the body is also 20 coulomb. That means charge is independent of the speed. But mass is not independent of the speed. Mass depends upon speed. How? So there is a relation, mass is equal to m naught divided by 1 minus v square by c square. So what is m naught? M naught is the rest mass. If a body is at rest, if you measure the mass, that is m naught. And this m is mass of body moving at what speed? At v speed. So here v is there. What is c? C is velocity of light. Velocity of light. Now see, this is the mass of a moving body. This is the mass of a rest body. So this mass of the moving body is always less than the mass of rest body. Why? You see, if there is a speed, so v square, and you see, c is very large. What is the velocity of light? 3 into 10 to the power 8 meter per second. That is high speed, very high speed. So if a body is moving with this v, and if you take the ratio v square by c square, it is always less than 1 because c is very large. V is just 60 km per hour, 20 km per hour, like that. So v is very, very small than c. So v square by c square is very, very small than 1. So 1 minus something, you will get denominator is less than 1. If denominator is less than 1, then m is equal to m naught by less than 1, that is m is less. Sorry. So m is more. So for moving body, mass increases because m is equal to m naught by this. So denominator is less than 1. So m is always greater than m naught. So we can say mass of a moving body is always greater than the mass of rest body. But charge is independent of the speed. So now we will discuss the various property of charge. You can write the note also. Property of charge. First property, additive nature of charge. Additive nature of charge. What mean by additive nature of charge? Suppose you take a body. In this body, in various locations there is charge. Here it is 1 coulomb. Here it is 2 coulomb. Here it is minus 3 coulomb. If somebody will ask, what is the charge of this body? You just simply add. The charge is added algebraically because it is a scalar quantity. So what is the charge of this body? You just add all the charge located at various places on the body. So it is 1 coulomb plus 2 coulomb plus minus 3 coulomb is equal to what? 0. So charge of this body is equal to 0. So we can say the total charge of a body is equal to algebraical sum of charges located at different positions inside the body. So you may write the note also. You write total charge of a body. Total charge of a body is equal to algebraic sum of charges. Algebraic sum of charges located at different position at different position, inside body. So this is the first property of the charge. Second property, conservation of charge. Conservation of charge. I have already discussed this property, that is conservation of charge. So what is conservation of charge? Charge can neither be created nor be destroyed, but can only be transferred. The algebraic sum of all the charges in any isolated system, or you can say closed system, is constant. So that is called second property of the charge. Third property is quantization of charge. So what is this property? Suppose I will tell, give me 1 pen or 2 pen or 10 pen, but you cannot ask give me 1.5 pen. So you can ask 1 pen or 5 pen or 15 pen like this, but you can't say give me 1.5 pen, okay, or give me 1.2 book. You can ask for 1 book or 2 book. So that means similarly charge of anybody is expressed as plus or minus n. This n must be an integer. So charge of anybody is equal to n times the E. So what is E? E is the fundamental charge. What is this value? 1.6 10 to the minus 19 coulomb. So charge of anybody is either 1 times this, 2 times of this, 3 times of this, 100 times of this. That means it is that property is called quantization of charge. Charge is always expressed in integral multiple of fundamental charge. That means charge of anybody can be plus 1e or plus or minus 2e, like this. So this 1, 2, 3 all are the integer. So that property is called quantization of charge. So let us discuss a test your understanding. So you see, today we will discuss test your understanding. That means how your concept is clear. According to that, take an example, test your understanding 21.1 of the book. Question is, does plastic rod weigh more, less or the same after rubbing with fur? Second question, what about the glass rod after rubbing it with silk? Next question, what about the fur and the silk? Okay. So now let us solve the problem. You see, first question. Plastic rod weighs more, less or the same after rubbing with fur. Suppose this is your fur. This is your plastic rod. If you will rub this between fur and plastic rod, what will happen? I have already discussed in this problem that in the previous example I have discussed this. So when you will rub fur with plastic rod, what will happen? Some electron will transfer from fur to plastic rod. That means here plastic rod will become negative charge, fur will become positive charge. Question is, after rubbing, does plastic rod weighs more, less or same? You see, after rubbing, what will happen? Some electron will add to the plastic rod. That means electron has mass. What is the mass of electron? I think it is 9.1 into 10 to the power minus 31 kg. It is very small amount. But some electron will add in the plastic rod. If some electron will add in the plastic rod, mass will increase. So we can say first answer, first A bit answer. Question was, what does plastic rod weighs more, less or same after rubbing with fur? Answer will be more. Mass of the mass of the plastic rod will be more. Come to second bit. Second bit, what about the glass rod after rubbing with silk? We know glass rod. Suppose this is glass rod. You add or you rub with what? Silken cloth. So if you rub, what will happen? Some electron will transfer from glass to silken. So glass will be positive, silken will be negative. What is the question? What about the glass rod after rubbing with silk? So here some electron will be left from glass to silicon. So there is a deficiency of electron in the glass. So here mass of the glass will decrease. Mass of the glass will decrease. Okay. Third question. What is about the fur? What is about the fur? You see, in case of fur and plastic rod, electrons lose by the fur. That means here deficiency of the electron in the fur. That means mass of the fur will decrease. Mass of the fur decreases. And what about the silk? What about the silk? So when we are adding glass with silk, some electrons are added in the silk. So that means the mass of silk now increases. Mass of the silk will now increases. Okay. So this is about the characteristic of charge. Next is method of charging. Method of charging. How you will charge a body, uncharged body. So there are three methods. One is charge by conduction. Second one is charge by induction. Third one is charging by friction. So we have already discussed this charging by friction. So now we will start discussing about the how you will charge a body by conduction process. So conduction process of charging or charging by conduction. So what will happen? Here charging by conduction process means you will there is a direct contact between charged body and uncharged body. Okay. So take an example. Suppose this is a body which is charged body, and this is which type of charge? Negative charge body. Let us say, so here excess of electron will create negative charge. So here let us say charge of this body is Q. This Q is a negative charge. Now you bring another body of same shape, same material. Okay. So here the charge of this body is 0. Let us say charge of A is equal to, this is A body, this is B body. The charge of A body is Q, charge of B body is equal to 0. That is uncharged body, this is charged body. So there is a gap between these two bodies. Now what I will do, I will directly contact A body with B body. This is A, this is B body. Okay. So what will happen? If you directly contact with charged body with uncharged body, you will observe, you will see the charge is divided. The charge is divided equally among these two. So here the charge of A and charge of B will be same. So what was the initial charge? Q. Here what was the charge? 0. So what is the total charge? That is Q plus 0. So here Q plus 0 is equal to Q, which will be divided equally. So charge will be divided equally under what condition? If there is same shape, same material, then charge will be divided equally. But if there is different shape or different material, charge will be divided proportionally. So this is called charging by conduction process. That is called direct charging. Okay. Second one is charging by induction. Charging by induction. Charging by induction process. So what is charging by induction process? You see, suppose this is a charged body. Let us say this body is A. Let us say this is a negatively charged body. This body is kept on a insulating stand. This is a insulating stand. Okay, this is a insulating stand. On the insulating stand, there is a conducting body, that is A, and this charge of this A body is A. So this is called charged body. This is called charged body. Clear? So now you bring another uncharged body. You bring, this is B body, which is uncharged. No charge of this body. So now, this is initial case. Now, if we will bring this uncharged body very nearer to charged body, this is second step. Second step is what? This is the charged body A. You bring this uncharged body very close to A, but don't contact directly. So there is very small gap between A and B. So what will happen? We will observe that some positive charge of this body will be attracted nearer to this A, and the negative charge will come to this side. That means this negative charge of A will attract positive charge of B towards it, and it will repel to the negative charge, so that negative charge will come far away from this A. And this charge is called inducing charge. This charge is called inducing charge. And this charge developed near to this A and away from this A, that is positive and negative, are called which charge? Induced charge. Induced charge. Okay. But what is the charge of this body? If I will say, what is the charge of this body B? You can say, sir, the charge of this B body is equal to 0. Why? So here plus, here minus, total charge is equal to 0. And you see, this positive charge is called bound charge. This positive charge is called bound charge, because this charge is bounded by this negative charge. But this negative charge is repelled by this negative charge. So this charge is called free charge. Why it is called free charge? Because this A is repelling to this negative charge. If I will give some external contact, then this electron can move to outside. That's why it is called free electron, but free charge. But this charge is bounded by this negative charge. It is called bound charge. Okay, and you know, so there is a property that induced charge, this induced charge, the value of induced charge is directly proportional to the amount of inducing charge. If inducing charge is more, induced charge is also more. If inducing charge is less, induced charge is also less. Just take an example. You are staying in an apartment. So these two are neighbor. If some sweets will come to this neighbor by their guest, so if 2 kg sweets will come, 200 gram will share to this neighbor. If 4 kg will come, 4 kg sweets will come to this neighbor, then he will give 400 gram. That means induced charge is directly proportional to the inducing charge. Another factor is that if the distance of separation between these two body, induced charge body is less, then the magnitude of induced charge will be more. If the distance of separation is more, then induced charge decreases. So we can say the induced charge is inversely proportional to square of the distance between induced and inducing body. R is what? R is distance between inducing and induced body. Okay. So now question comes. So how will charge this uncharged body? So third step, what will do? So this is your step number B. This is your step number B. Third step, this is your A body. This is A, charged body A. Okay. So now what will do? You just connect this B body to an earth. This is earth. So you connect this B body to the earth by electrical wire. So what will happen? This negative charge will move towards the earth. Or you can say earth has infinite capacity of the electron. Here negative charge indicates deficiency of the electron. So if we connect this side to the earth, what will happen? The electrons from earth will move to vacant, to fulfill this position. That is, here there is a deficiency of electron. So that deficiency of electron will be compensated by the electrons from the earth. Or you can say this negative charge will move towards the ground, or electron will move towards the body, so that this side will be neutral. Okay. So now this is step number C. Then third step. Then fourth step, disconnect this earth connection from the body. So fourth step, this is negative charge body A. This is the start. So now what will do? You disconnect this earth connection. If you disconnect the earth connection, again positive charge will stay here, because this positive charge is bounded by this negative charge. Clear? So it will bounded, so this positive charge will come to this side. You have already disconnected the earth. Final step, this is D. Final step, what will do? Remove this A. Remove this charge body A. So you will get only B. So if there is only B, what will happen? This positive will repel this positive will repel this positive. That means this positive charge will uniformly distribute over the B body, because there is no negative charge. So initially this negative charge was attracting this positive charge. But if this negative charge body is removed, this positive charge will uniformly distribute. Now, so what was the initial status of this B body? It was initially uncharged body. Now, this body B becomes positively charged body. How it is possible? This is possible by induction process. Then, what is the induction process? So, induction process is that, so when an uncharged body is brought to a charged body, some charge will be induced in this body. So that process is called induction process. Okay. So this is about your so the basic concept of charge. So I discussed the charge, what do you mean by charge, what is the properties of a charge, and last one I am discussing here. So I am giving an homework to you. So I had explained how you will create a positive charge body by taking an uncharged body. Okay. Suppose you take an uncharged body, how you will make it positive charge? So I have explained, bring a negative charge body to the uncharged body, and I have given the 5 process. So your homework is that write down the steps. Write down the steps to create a negatively charged body. That means you will take a uncharged body, but you have to create a negatively charged body. So write down the steps to create a negatively charged body. So just you can only write the steps. Okay. So how you create a uncharged body to a negatively charged body. So this is your homework. You can practice. So last part is here. What are the types of material according to the charge concept? So the material, any body can be divided into three types. One is conductor, another is insulator, last one is semiconductor. So what is my conductor? Conductor is that through which through which charge can flow easily, or you can say charge current can flow easily. So that is called conductor. Conductor conduct. Bus conductor will conduct passenger. Thermal conductor will conduct heat energy. Electrical conductor will conduct what? Electron. Electron is which particle? Charge particle. So conductor is that through which charge can flow easily. So what is the characteristic of the conductor? Here number of free electrons available is more. There are more number of free electrons available in the conductor. What is the example? Any metallic conductor, you can say it is a good conductor of charge. So example is copper, aluminum, gold, silver, etc. So these are called conductor. Then what is insulator? What is insulator? Insulator is that through which charge cannot flow easily. That means the number of free electrons are very poor, because free electrons carries the charge particle and they move from one point to another inside the conductor. But in case of insulator, number of free electrons are very less. So charge cannot flow easily. What are the example? Example is wood, paper, mica, sheet, like this. Okay. So generally non-metals are insulator. So here conductivity is very poor. In case of conductor, conductivity is very large. Okay. Next is your semiconductor. From name itself, it indicates the conductivity lies in between conductor and insulator. So conductivity lies in between insulator and conductor. Here number of free electrons is less than a conductor, more than insulator. Or you can say number of free electrons is intermediate. So this is about the first class of electrostatics. So I discussed what is charge, how charge is produced, what is the characteristic of the charge. So what is the types of material like conductor, insulator, semiconductor. So next class we will start Coulomb's law with some example and some exercise problem. So I hope you enjoy this video, and I need some comment, okay, so that I can modify or I can improve the material. So all the best. We will meet in the next class. So try to share this video. Okay. Bye.